Have you ever noticed that shiny copper doesn't stay shiny forever? A brand new copper penny has a bright reddish-orange color. Fresh copper pipes, copper roofs, and copper statues all start out looking warm and metallic. But give them enough time, and something strange happens. They slowly turn brown, then darken, and eventually develop that familiar green coating. You can see it on old buildings, church roofs, historic monuments, and even the famous Statue of Liberty. At first glance, it almost looks like the metal is rotting away, but surprisingly, the exact opposite is happening. That green layer is actually copper's secret defense system. Instead of weakening the metal, it helps protect it from further damage. So why does copper change color, and what exactly is that green stuff? Let's find out, right here, on History of Simple Things. Humans have been using copper for more than 10,000 years. It was one of the first metals ever worked by ancient civilizations because it could be shaped without requiring advanced technology. Ancient Egyptians used copper for tools, jewelry, and decorative objects. The Greeks and Romans used it extensively in architecture and plumbing. Over time, people noticed that exposed copper objects gradually changed color. The Romans even had a name for the green substance that formed on copper surfaces. They called it verdigris, a term still used today. Interestingly, artists and painters later harvested verdigris as a green pigment for artwork and manuscripts. For centuries, people observed copper turning green long before they understood the chemistry behind it. Today, science can explain exactly what's happening. When copper is freshly exposed, its surface immediately begins reacting with oxygen in the air. This first reaction creates a very thin layer of copper oxide. The process is similar to how iron reacts with oxygen to form rust, but the outcome is very different. Initially, the copper oxide layer appears dark brown or nearly black. If you've ever seen an old penny that looks darker than a new one, that's largely because of this oxidation process. At this stage, the metal isn't green yet. That comes later. The oxide layer continues to interact with the environment, and the chemistry becomes more complex over time. The famous green color develops when copper is exposed not only to oxygen, but also to water and carbon dioxide in the atmosphere. These substances react with the copper surface over many years, forming compounds known as copper carbonates. One of the main compounds responsible for the green appearance is called basic copper carbonate. As layer after layer develops, the surface gradually changes from brown to a distinctive blue-green color. This transformation can take years or even decades depending on environmental conditions. Areas with high humidity, frequent rain, or salty ocean air often see the process happen more quickly. That's why coastal structures made of copper often develop their green coating faster than those in dry inland locations. Perhaps the world's most famous example of green copper is the Statue of Liberty. When the Statue of Liberty was completed in 1886, it wasn't green at all. It had the natural reddish-brown color of freshly exposed copper. Over the following decades, the statue slowly changed color as its copper skin reacted with the atmosphere. By around the early 1900s, the familiar green appearance had become well established. Many people assumed the green color was painted on, but it wasn't. Nature did all the work through chemical reactions occurring over many years. Today, the statue's green coating is considered one of its most recognizable features. At this point, you might be wondering, if copper is reacting with the environment, isn't it corroding? Technically, yes. But copper corrosion behaves very differently from iron rust. When iron rusts, the rust flakes away and exposes fresh metal underneath. This allows corrosion to continue deeper and deeper into the metal. Copper's green coating acts differently. The patina forms a stable, protective barrier that sticks tightly to the surface. Once the patina develops, it dramatically slows down further corrosion. Think of it like a shield. The outer layer takes the abuse from the environment so the metal underneath remains protected. This is one reason copper roofs and copper architectural features can survive for hundreds of years. So, does all green copper look the same? Not exactly. The exact color depends on the environment and the chemicals present. In some locations, the patina appears more blue. In others, it may look bright green, dark green, or even turquoise. Near oceans, salt in the air can contribute to additional copper compounds forming on the surface. Industrial pollution can also affect the final appearance. This means no two copper structures age in exactly the same way. The chemistry is similar, but local conditions create unique shades and patterns over time. Copper's transformation from a shiny reddish metal to a weathered green surface is one of the most fascinating examples of chemistry happening right before our eyes. What might look like damage is actually a natural process that helps preserve the metal for decades or even centuries. Through its reactions with oxygen, moisture, and carbon dioxide in the air, copper creates its own protective coating, allowing it to withstand the elements far better than many other metals. So the next time you spot a green copper roof, an old church steeple, or the Statue of Liberty's famous color, you'll know there's more to it than simple aging. That green patina is a record of time, weather, and chemistry all working together. It's a reminder that sometimes nature's way of protecting something can completely change its appearance, and in copper's case, create one of the most recognizable colors in the world. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.